Hi, and good afternoon, everyone. It's my great pleasure to present to you today the CARES project. First, I would like to say, though, that under normal circumstances, that is, not being in the middle of a pandemic, I would have had a lot more results from the project to present today than I'm actually having, and I deeply regret that. This is due to that the COVID-19 outbreak has had a severe impact on many of the key activities planned up until the first 19 months of the project, where we are right now. So we are now looking for an extension of the original 3 years duration of the project with up to about 1 year. Thus, hopefully, the final results can be presented at some future H2020 RTR conference. So to start with, the overall objectives of the project: to reduce the hurdles for practical applications of remote emission sensing, RES, and to make it a widespread means of both monitoring and enforcing improvements in road vehicle emissions. Then in a bit more detail, why is this important? Why should we care about CARES? Well, to start with, poor air quality is still a big issue in many European cities, and road transport persists to be the main source to urban air pollution, such as nitrogen dioxide and particulate matter. Further, the failure of the EU emission legislation in the past and the lack of knowledge about emissions in real-world traffic have hampered improvements in urban air quality for long now. And the best example is probably Dieselgate. Thus, solid real-world emission surveillance programs and associated measures need to be implemented and further improved to improve air quality. So this is where remote emission sensing comes in. The task of CARES is, by further development and refinement of RES technologies and associate measures, promoting a widespread deployment of these technologies to demonstrate how it can lead to reduced emissions and improved urban air quality. This figure here to the left shows or exemplifies today's situation in Europe, characterized by the ad hoc nature of RES applications. And to the right, a vision of how the future could look like after the implementation of the project. Then just very briefly about the consortium behind the project. CARES is an international cooperation flagship project comprising 16 European partners in 10 European countries, plus an additional 3 international partners from China, ensuring a strong international collaboration. An important feature of the CARES project is hardware development. Commercial RES systems, seen to the left in this figure, developed in the US, have been around already since the late 1990s. And there are today presently 2 suppliers in the US offering their measurement services also in Europe. These 2 technologies are based on very similar principles, but with different twists on the hardware side. The basic principle is that pollutant concentrations are measured with a very high time resolution in the diluting exhaust plume behind each individual passing vehicle through either horizontal or vertical scanning by infrared or ultraviolet light beams. The commercial systems today have some drawbacks though. One is the snapshot nature of the emission measurement, and another one is the limited accuracy and representativity of the measurements of particulate matter. This will be overcome in CARES, the right side of the slide here, by further developing and refining two complementary RES technologies, plume chasing and point sampling. The plume chasing technology is an innovation brought forward by partners to the CARES consortium and is presently on the verge of commercialization. Emission measurements instruments are mounted on board a car or a van, driving behind for a couple of minutes the vehicle, the emissions of which you want to measure. Today's systems measure only nitrogen oxides, but CARES will enable the inclusion of also particulate matter measurements and to make the instrument more user-friendly, to be operated by unskilled personnel, such as the police, to detect high-emitting, suspiciously tampered vehicles for enforcement. Similar to the plume chasing technology, the point sampling technology is an innovation brought forward by partners within the CARES consortium, using low cost, low power, and small size, high time resolution sensors to measure the concentrations of particles in the exhaust plumes of passing vehicles from the roadside. Photoacoustic sensors for measuring soot particles or black carbon, and diffusion charging sensors for measuring the total number of particles emitted. Parallel measurements of carbon dioxide as a tracer of the exhaust plume enables the derivation of individual vehicles' emissions. Another important feature of the CARES project is software development, taking care of the massive number of data that can be collected by means of remote emission sensing. This work comprises the development of data infrastructures as such, as well as of different open source analytical tools and guidance documents aimed for supporting unskilled RES users. The figure shown in this slide shows an example of data compiled within the CARES project based on measurements of nitrogen oxide emissions from more than 600,000 diesel and petrol cars in various countries across Europe over a period of 10 years, distributed over the various EU emission standards, showing some of the great potential remote emission sensing has to, for instance, evaluate and track policy emission control purposes. The next important steps in the project will be taken as soon as the COVID-19 situation will allow resuming traveling and CARES partners working together in various European locations. The first next step will be emission characterization and technology validation experiments at a test track in the Netherlands, being followed by demonstrations of 9 RES applications that are highlighted in the CARES project, ranging from enforcement of individual high-emitting vehicles to policy steering, policy tracking, and informing vehicle purchasing decisions as some examples. And this will be done in 3 major heavily polluted European cities: Krakow in Poland, Milan in Italy, and Prague in the Czech Republic. With this, I conclude my presentation, and I'm looking forward to answer any questions you might have. Thank you very much for your attention.